Clean, flowing, fresh water. Upon seeing it, probably every human reacts positively and feels a calming sensation. We cannot live without it. Water vapor is transpired into the atmosphere by forests during photosynthesis. The water vapor condenses and falls back to Earth as precipitation, thus maintaining the all-important local water cycle. Old-growth forests are the most effective at the job, propagating rainfall down the line to keep forests watered and streams flowing. Water moving through densely shaded, undisturbed old-growth forest is some of the finest on Earth, having been filtered and purified through thick forest soil. Much of that water seeps far below ground, keeping underground aquifers replenished. In dry periods, old trees with deep roots are able to access that water, keeping the forest hydrated and the water cycle working. Young trees lack this capability. Where forests are cleared or removed, water tends to run off the land and less water can penetrate down to aquifers. The result is drier land, more droughts, less vegetation, and more severe storms with more frequent flooding when precipitation does occur. Without adequate forest cover, soil is washed away into rivers, damaging both land and aquatic habitats. Old forests, managed by nature and co-evolved with local conditions over thousands of years, actually helped create those environmental conditions. The control they exercise over the climate and hydrologic cycle are the only way to maintain the stable, beneficial environment that we desire and need. All the characteristics of these old forests are important to the whole. Not only the trees, but all plant and animal life. And just as critical is the microbiome, the microscopic life forms that abound on and in the forest floor. The mix of tree species, sizes, and ages provides structure that supports all other members of the forest. Decaying logs remain water-soaked and provide shelter and food for many organisms. Other dead plant and animal material is decomposed, recycling nutrients to build new life. Streams are kept cool in the shade of tall hemlocks. Moist woods grow lichens, algae, mosses, liverworts, and fungus species. Globally important tropical forests are rapidly being destroyed in the Amazon and Congo basins. Northern Hemisphere boreal forests are also being logged. Increased temperate forest cutting is now planned in the United States, including heavily forested New England. There is growing worldwide recognition that we must preserve and promote old, nature-managed forests. In the last several years, a number of scientific research papers have been published, emphasizing the need to prioritize the protection and promotion of old forests across the globe. One such paper introduced a new term, proforestation.
So proforestation is a scientific term that we coined, and it's published in the peer-reviewed scientific literature to mean just letting forests grow. It's nothing new. We just needed a more specific term to orient people to that process. I found out that there weren't even really specific words to describe that. So needing to have a word that meant the process of letting natural forests adapt and evolve and grow and respond to disturbances as forests have for millions of years was really important. Proforestation describes that process.
As the glaciers receded at the end of the last ice age, forests reestablished themselves in the northern hemisphere. And during that period, the climate was incredibly benign, called the Holocene era. It was stable. It was relatively conducive to human settlements. Prior to the Ice Age, humans were just nomads because they couldn't settle down because of the variability of the climate. In 2023, an interesting paper was published which pointed out that all of human civilization, from agriculture, urbanization, to everything we think of that's happened in the last 10,000 years, has happened as a result of this stable climate. And what was responsible for that? Well, it was primarily forests on land and the oceans. They kept the amount of heat-trapping carbon dioxide in the atmosphere at a level that just gave us the perfect temperature and climate conditions in much of the world. When the Europeans arrived in North America 400 years ago, they saw forests as a resource and as a barrier to development. They needed to clear it for agriculture, for urbanization, and they needed to harvest it for building materials and fuel. That means that forests were considered to be a natural resource to be exploited for human purposes, and the motivating factor has always been economics. On the other hand, natural forests function according to the principles of ecology, meaning that they are natural systems that respond to natural processes. All the rainfall, all the soil mineralization, all of the species that are in a forest. Forests have the largest number of species of any land-based ecosystem, and these combine to make forests highly resilient to changes. When forests are treated as a resource, as we have done, we have managed to eliminate the long-standing processes that they have provided. They provide water and moderate the climate in a way that has provided a livable planet for all of us.
One of the arguments that one hears a lot regarding forests is the idea that we have to rehabilitate forests. And the idea that the way you do that is through manipulation of the forest stands, primarily through logging. One of the problems with that is it's human selection rather than evolutionary processes. One of the problems with that approach of fixing the forest is that these selective practices are unable to account for the genetic makeup of these different trees and shrubs and their interactions. You can't tell by walking out there which traits might be in the tree. And so when you go in and select the trees and you take, say, 50% or 40% or whatever percent of the trees out of a stand, you may eliminate particularly the rarer traits that might be 1 in 100 trees have some trait that gives them an ability to survive some sort of climatic or insect or disease kind of outbreak. And so when they say they're creating resilience in the forest stand, they may be, in many cases, degrading the forest stand's resilience. When you log, you remove a lot of the carbon that would otherwise be stored there. And human carbon releases in the atmosphere is leading to the climate warming and climate change. That carbon that's removed by logging is released quickly into the atmosphere. In Oregon, for example, the biggest source of carbon release comes from logging industry, not from transportation, not from forest fires or anything else. And even when you have a forest fire or you have a beetle outbreak that kills some of the trees, it takes a long time for that wood to rot under natural conditions. In a lot of parts of the West in particular, because it's so dry, you'll have snags that last 100 years or more, and the roots in the ground for 100 years or more. And that's all carbon being stored, so that it's released much more slowly into the atmosphere. So one of the arguments against the logging is that you're actually releasing more carbon into the atmosphere, which is contributing to climate warming, which is contributing to things like more wildfires and insect outbreaks, which follow those climatic conditions.
I'm standing right now in the middle of a quite biodiverse, advanced stage, second growth forest, one that has been harvested. I'm sure this whole area was completely cleared at one time. But there are trees in here that are maybe 70, 80, 90 years old, maybe a few that are older. I'm standing next to a big old hemlock tree, which is covered in moss, indicating that it's probably been here for a while. And if you look down on the ground, there are lichens, those green lichens on that broken branch that's down there on the ground. There are many, many different ground plants that one can see growing here. I can see a little hemlock seedling, which is a good sign. It means that this forest is continuing to regenerate. And we can't even see the millions of different microorganisms in the soils that make this soil suitable for a forest of this type, or any of the species that are in the treetops, which are totally different from what's on the ground. Instead of treating forests as a natural resource, proforestation and the protection of existing forests treats forests as essential components of Earth's operating system. They are vital organs of a living planet, along with other ecosystems. Just think of it. Think of the Earth as living.
Particularly in the east, we have very few relic stands of forests that are virgin, intact forests. I've been in a fair number of these patches of old-growth forests that are found around the Northeast and the Southern Appalachians as well, and down in Florida. And one of the things you see is that they resemble, in many ways, the old-growth forests in the West. What I mean by that is they tend to have more downwood on the forest floor, large diameter trees on the forest floor that are dead. That's a very important physical component to a forest ecosystem. There's more snags. One of the things that I see that foresters tend to do when they say they're fixing the forest is they eliminate the snags from the forest, and they preclude the creation of snags in the future too, because when they say they're making the forest healthy, they're reducing the ability of natural processes to select either insects or drought or whatever mortality in trees. So they eliminate the creation of snags in these forests. And in the east particularly, so much of the forest stands have been logged in the past, cut over for farming, etc., that we mostly have young forest stands, and people have what I call landscape amnesia. They don't know what the forest used to look like. When I lived in Vermont, shortly after I arrived there from the West, I went to a meeting. And in this meeting, it was to determine whether to log a nearby piece of state land. And I remember every person got up and said, we need to log here. We want to create more deer habitat, like there's a shortage of white-tailed deer. And because the deer like the early successional forests. And finally, this guy gets up and he says, we got to address the old growth issue here, the old growth problem. Finally, somebody who gets it. And then he proceeded to say, we have too many big trees here. We got to log them. And I'm shaking my head. I just couldn't believe that that was the issue. And again, this gets to the landscape amnesia point where the people there in Vermont had no idea how the old growth forest looked. And the biggest trees in Vermont, you can look it up, the record-sized trees are all in cemeteries because they haven't been logged in a couple hundred years. And one of the things I would do when I was in Vermont, besides finding the few patches of original forests, is I went to record the big trees. And surprisingly, you know, they're not quite as big as what you'd find out west, but some really sizable white pine and other large maples, etc., that were not typical. And the other thing you would see in the forest, lots of skinny little trees, and then there might be one big maple along an old fence line because that maple grew up in the old stone fence and hadn't been logged in 200 years. And 200-year-old farmhouses would have big trees in front. And so that's what the place looked like at one time. And you just don't see it in a continuous forest stand in very many places around the East Coast. The Adirondacks, I believe, has some of the largest virgin old growth there. And I've gone in there any number of times. To me, anyway, it's significantly different. I see more logs on the ground. I see more snags. Of course, very large diameter trees. And typically, a lot of times, less understory shrubs. And you see the same thing out west in old growth forests. Knowing what that landscape looks like gives you a different view of what could be possible. And the possibility for proforestation to allow forests to naturally recover with ecological selection going on, evolutionary selection occurring without human interference, we will get the most resistant forest that way, rather than trying to second guess things and use human manipulation to achieve that.
There is great concern today about forest fire, particularly in the western United States. Some think the best course of action would be to heavily manage forests to prevent fires. Is that a good idea?
The conditions for large wildfires require extensive drought, low humidity, and high winds. And the time of year when, at least out west, those conditions exist is in the summer. And in the summertime in New England, it's usually moist and you have rain periodically, heavy rain. So you don't get large wildfires very frequently. Some studies I've seen for Vermont, for example, suggest that large wildfires happen every 1,000 years or whatever. In New England, manipulation of the forest historically, and when I say historically, before there was a lot of European settlement here, was small scale, only affecting very small areas around villages and so forth. So these kinds of events are much rarer in New England. And so the idea that you're mimicking natural processes through logging or prescribed burning is a fallacy. And these forests around here, the natural processes that affect them tend to be more disease, hurricanes, microbursts, ice storms in the winter. And most of those affect things on a very patchy kind of condition and don't tend to affect tens of thousands of acres at a time. And even when they cover a large area, the severity of mortality will vary greatly over, say, 1,000-acre size. And you have to remember, most of these things are episodic. They don't occur every year. They might occur once in a couple of hundred years. I remember I went to a microburst where a lot of the trees had been broken off in the Adirondacks. I think it was an area of like almost 50,000 acres. But even within that 50,000 acres, it wasn't like every tree was laying on the ground. And that's the same thing in the western United States with so-called high-severity fires, where a majority of the trees might die from fire. What you find is that it's a mosaic. And people don't realize that when they say, oh, well, the fire burned 100,000 acres at high severity. Actually, when you look at the percentages, it's often like 10 to 20% of that 100,000 acres burned at high severity, and then you'd have some at mixed severity and some at low severity or not burned at all. And so there's a misnomer there in the sense of the way that people look at that. And so you have to realize that these natural processes tend to be patchy in the way that they affect the forest. And that affects how the distribution of plants and animals are. And there are, I hate to use, I'm going to do it, I'm going to anthropomorphize. You could say that there are a lot of wildlife and plant species that live in mortal fear of green forests because they're so dependent on the dead trees and the snags that are there. So, for example, in the Northern Rockies, where I lived for many years, 45% of the bird species utilize dead trees at some point in their life. It might be they feed on them, it might be they're cavity nesters and live in the cavities, it might be that they roost in them and so forth. But it's not just that. There's more bee species in areas with high severity fires. There's more mushrooms. Even the fish in the streams get bigger and are more abundant after a high severity fire because of all the wood that's washed into the stream, which creates better fish habitat. So as a result, you have all these animals and plants that need these kind of episodic events that cannot be readily created by logging. It may surprise most people that there are hundreds of species of native bees, most of which live in the ground or in rotten logs or logs that are decomposing on the ground. And that habitat is in short supply in a lot of cases, especially in manipulated forests. So if you have a forest fire, for example, you have a lot of dead wood that falls on the ground. That creates the habitat for native bees. That opened up the forest. There might be more flowers for butterflies and bees and other insects that rely on pollen and do pollination, but the physical habitat is still there, whereas when you log and sanitize the forest, you remove those physical components, and therefore it's not the same effect on the forest stands. And these native species of bees, for example, are really significant pollinators of most of our plants, including domestic, orchards and so forth. A lot of the pollination occurs from native bees, not just honeybees. A lot of people misunderstand the definition of biodiversity. From a conservation biology perspective, the way you look at biodiversity is native species represented in something approaching their natural distribution that has to do with where they're found, their age, population density, etc. And some people think it's just a total number of species. And this leads to real misconceptions about biodiversity protection. Where you're manipulating, you get a lot more invasive species there, and that adds to the total number of species. And people say, well, look, there's more biodiversity around where the humans are manipulating things, when in fact the species that tend to populate those areas tend to be generalists that can thrive in any disturbed site. And that, of course, happens in our natural patches as well by natural processes, but what we see a lot more of today is when you have a whole lot of disturbance through forest manipulation, you tend to increase the population of generalists as opposed to specialist species, and you may even get a reduction in biodiversity. But even if the total number of species goes up, if you've changed the ability of the native species to survive there, then that's a reduction overall in biodiversity, and people have to understand that biodiversity definition depends on having native species distributed in something approaching what would happen under natural, unmanipulated conditions. And a failure to understand that, we see it all the time in people that are arguing that manipulation will lead to increased biodiversity. One of the things that people have to be aware of is the bias of the, quote, professional foresters. I went to forestry school, and what I learned there was mostly how to cut down trees to make timber and build roads and so forth. I wound up taking many, many ecology courses eventually, rather than just that strict utilitarian approach to things. But a lot of people come out of these schools, whether it's in forestry or range or whatever, and their bias is, whether they're conscious of it or not, is to produce, whether it's wood or grass for livestock or wood for the lumber industry. And so they tend to look at a forest from that perspective, that they're doing good when they increase the growth of trees and make trees grow faster so that they can be cut sooner so that they can be turned into lumber. One of the first things I do when I look at scientific papers, I look to see what the association is of the authors, and most scientists are pretty good about not trying to be openly biased, but there's unconscious bias in there. And if they're at a forestry school, you have to remember they get their money often for grants and research from the timber industry. So that affects the kinds of questions you ask. An example of that is I was in wildlife biology at the University of Montana, and I remember we had a session one time, and we had a number of professors there, and somebody asked why there was no studies on the effects of hunting on wildlife. And they all kind of looked at each other sheepishly, and they said, well, we get most of our funding for research from the Fish and Game Department, and they don't want us to ask that question, and there's lots of other things we can study, so we don't go there. And that's the same with forestry schools and so forth. So you have to be aware of the unconscious bias that you get out of research that's done by these schools. Again, they're not necessarily purposely being biased, but the kind of question you can ask affects what you get. climate really affects what happens to forests. And what we see out west a lot is people are saying we have more wildfires today than we had in the 1970s. But that's a sliding baseline, which you see all the time. If you look back in time, even in the western United States, you'll find that in the early 1900s, there were huge areas that burned, much more than even today, because we had drought conditions. In 1929, there was a little thing called the Dust Bowl happening. 50 million acres burned across the West. 50 million acres. Today, if 10 million acres burn in a season, that's considered a huge amount. So we have a distorted view of what can occur. And then through the 1930s and into the 1940s, the climate got cooler and moister. And I can recall when I was first starting in college, my professors were all worried about the ice age that was happening. There was worry, how are we going to feed ourselves if glaciers come out of Canada and cover up the Midwest and we can't grow corn there anymore? And what happened during that period is you had much fewer fires and acreage burned because it was moister, so you had fewer ignitions, and even when you got ignitions, the fires didn't spread well. And then, due to human carbon inputs, it finally started to reverse that natural tendency towards an ice age, cooler conditions, and brought about what we see today, where we have increasing temperatures, which favors more wildfires, more insects, and so forth. So this idea that fire suppression was successful, no, nature was good at suppressing fires when the climate was cool and moist. And that totally overwhelms anything that humans were doing to, quote, suppress fires. And the thing that you have to realize, too, is most fires, even today, are small. They burn less than a couple of acres. Like 98, 99% of all fires are less than 5 acres. And they go out on their own. But we claim we'll put firefighters on them, and we say we put out the fire when the fire was going to go out anyway. And then when you have the right conditions, and they are drought, low humidity, high temperatures, and particularly wind, every big fire that's ever occurred is a result of those conditions, whether it's in the east or the west. And wind is the big factor because it blows embers ahead of the fire front. And that's one reason why things like thinning and prescribed burning are ineffective, because the wind will blow burning embers over, around, and through such things. When you reduce the density of trees in a forest, you reduce the moisture that's on the ground. You also open it up to wind penetration, so you actually increase and enhance the factors that lead to more rapid fire spread. And that's another thing that's seldom admitted, that a lot of these manipulations that are done under the excuse that they are going to reduce fires, they are usually ineffective for precluding fires. Most of these manipulations have no effect on fires because fires never encounter them. There was a fire called the Eagle Fire out in Oregon. Embers were blown across 1.5 miles of the Columbia River and started fires on the western side of this river. There was no fuel there in the Columbia River, and it didn't stop that fire from burning. And you got lots of places in Southern California where you got 16-lane highways, parking lots, all kinds of stuff that have no fuel, and the fires just still burn down whole communities because the wind blows the embers to the next vulnerable place for the fire to continue.
There is a persistent myth that Native Americans actively managed the forests of New England by regularly burning them for various reasons, such as clearing underbrush for easier hunting. Frequent burning would have resulted in increased charcoal being washed into lakes and ponds, which would be detectable in sediment layers, but research shows that such burning only occurred in localized sites where indigenous populations were concentrated. The greater part of the New England forest was not manipulated by native people, and therefore was in its natural condition prior to European settlement. Fires increased, especially inland, after European settlement. Natural fires of significance were and are rare in moist New England forests. Today, however, there is increasing pressure to log forests, purportedly to prevent wildfires. This is an unjustifiable reason to log forests and can have exactly the opposite effect. There is rapidly increasing use of prescribed fires to reduce fuel in forests, but large fires in New England primarily occurred after Europeans cleared the forests, creating brushy and dry conditions. In fact, the acres burned each year and the average fire size have declined dramatically since the early 1900s, when New England's open agricultural landscape reverted to forest. The forests are generally becoming more moist, and there is no evidence of a dramatically increasing risk of forest fires. Claims that climate change will greatly increase forest fires in New England in the foreseeable future are not aligned with wildfire data and trends. Another stated purpose of some prescribed burns is to create and maintain open habitats in the name of increased biodiversity. However, such conditions are artificial, and periodic burning would have to continue indefinitely. Otherwise, nature will step in and immediately begin to return the land to forest here in the Northeast. And whatever plants or animals that may be artificially attracted would displace other residents.
A lot of the forestry management and manipulation is driven by human perceptions of what's good for the forest. And the human perceptions may not align with what a forest would say, so to speak. I've gone on field trips with foresters out west a lot, and I was with a group of foresters and others in a collaborative where they were saying they wanted to reduce the density of the trees, which they felt were too dense, and allow the trees to grow faster. And I pointed out to the group that trees that grow fast have wider tree rings, and actually when they die, they rot quicker as a result. That's one of the reasons why people who built houses in the old days wanted old growth trees, because the trees grew slowly and they had denser wood and it was stronger. So when they reduce the density of the trees, they now have trees that are going to rot quicker, which means it won't be in the ecosystem as long. And so animals and plants that depend on those dead trees are now going to be more limited. And the foresters are saying they had root rot and they needed the log. And I said to them, so what's the ecological role of root rot? They looked at me with a blank face. They didn't know. I don't know what the answer to that is either, but that's the first question I have. The assumption was because root rot kills some of the trees, that's got to be bad. And they don't like any mortality that happens naturally at all. The only mortality that's okay is chainsaws, what I call chainsaw medicine. They're going to fix the forest with chainsaws, but if the tree dies from an insect, the tree dies from wind, the tree dies from wildfire, or whatever, that's considered bad. And that's human values that are basically the industrial forestry paradigm that sort of dominates our thinking, because foresters go to forestry schools and what they learn there is how to grow trees for wood production, and that's their bias that they have as background. There are alternative substances we can build a lot of houses with. I remember being in Europe a number of years ago and noting that a lot of the homes there are built of stone or they're built of bricks and so forth. And I noted that to this German I was with. And he said, yeah, we love wood here, but we limit it just to like windowsills and cabinets and things that we can see. Why hide it in a wall? That doesn't make any sense at all. So the point is that there are alternative ways to build if that's what you're going to do. One of the arguments that one hears frequently is that humans are essential to manipulate landscapes because historically speaking, there was some manipulation of the landscape by humans, whether that was clearing the land for agriculture, And of course, in Europe and Asia and so forth, livestock grazing and those kinds of changes to the landscape. However, particularly in North America, but this could go around the whole globe, most of these plant communities that we're talking about that are natural plant communities have existed for a long evolutionary period of time without any kind of human manipulation. Now, it is true that manipulation has occurred, but usually they were small scale and did not affect the whole landscape. Particularly in North America, the first human colonists of North America came here perhaps 15, 16,000 years ago, and their population density was always quite low, and their technology was quite low. So your ability to manipulate large landscapes was pretty minimal. And of course, as technology has increased and as population has increased, we now have a large amount of the Earth's landscapes manipulated by humans, which makes it even more essential to protect those areas where human manipulation is minimalized. People will say, well, climate change is affecting everything. It's true. But we can still say that there are degrees of manipulation, and that someplace like the boreal forests in northern Canada, or quote wilderness areas around the country, have less manipulation than, say, an urban area like Los Angeles or Boston or someplace like that. So there are degrees of manipulation. And that's always been true. Even when you go back and look at the human use of the landscape, humans have always been concentrated in certain favorable geographical locations, and that's where the highest population density was and the most manipulation occurred. But it was not uniform across the landscape. And so we still have extensive areas of low human manipulation, and these areas should be protected and resist the attempts to do more manipulation in the case of, say, forested areas, logging, and prescribed burning over large areas. And my feeling is you should limit logging and so forth to as small an area as possible, rather than trying to say we need to do it everywhere to fix the forests. And in fact, what that does is it tends to degrade it.
Recently, there was a first-of-its-kind regional report called Wildlands in New England, Past, Present, and Future, that talks about the science and the history of the land in New England. And what the report did was identify areas that are termed wildlands, which refers to areas that are prioritized for natural processes with minimal human intervention, recognizing that we lived on this land for many years, but most of it we were not intentionally significantly altering the structure and function of the landscape, except just in very limited areas. And so the Wildlands Report is identifying areas that have an intent for natural processes, which is basically describing what proforestation is all about. Where are we allowing natural areas to adapt and evolve, specifically natural forests? E.O. Wilson and Thomas Lovejoy, who were maybe the, grandfather and godfather of biodiversity, were both really supportive of proforestation. They knew this was a term that was needed. They knew that proforestation is really important. It's nothing different than what people might call forest reserves, or a nature sanctuary, or a wilderness area, or what we expect in a national park. And E.O. Wilson talked about consilience, which is the jumping together of knowledge. And what I've found in terms of talking to people from around the world with different types of natural areas, different types of expertise, is everyone is understanding that we need to identify the literal lifelines of everything. And the fact that all these different disciplines are talking about it is a manifestation of consilience. And E.O. Wilson said that is something that we should not ignore. We need nature. There's no doubt about that. And the most important thing we need to do now is decide where that's going to be. And we know what the critical pieces are: our headwaters, our cold water fisheries, critical habitats, old forests, sufficiently large areas where the whole range of species can move and migrate. We need connections between these areas. This is our ecological lifeline for the future. And these natural areas have the full biodiversity that supports working forests and supports our farms and supports our mental health and prevents flooding and actually prevents fires, because these are wetter areas. Downed logs have 25 times the amount of water that the adjacent soil does. So you add this whole complexity to the system and it acts like a sponge. And so we need these sponges that are biodiverse, that provide this kind of repository for the rest of the landscape. And not making sure that we have that nailed down is really dangerous right now, because there is a lot of pressure to identify what are we going to do with every piece of the land. Are we going to put housing on it? Are we going to put renewable energy on it? Are we going to extract from it? Are we going to manipulate it? Are we going to mine it? What are we going to do with it, without understanding what it's doing for us and for all the other species on Earth? That's the core question that we need to grapple with right now. Forests are the most biodiverse land-based ecosystem, and that means that there's an incredible web of life above and below ground. Even up in the tree canopies, there's all kinds of species and interactions that we haven't even discovered yet, particularly the tiny things that are really what forms the basis of biodiversity and the basis of life on Earth. So we need to be really careful with what I call our ecological lifelines. And our ecological lifelines are the interactions between this web of life and the network of water that brings life to land and makes life on land habitable. I consider proforestation almost like a farmer considers seed corn. So your seed corn is sort of your reserve that you have, that's your basis for your farm, for your future. And we don't understand these natural systems, which is why we have to be really, really careful, and why we have to make sure that we set aside enough of these natural forests that are allowed to evolve and adapt, which is the only thing that we really know is sustainable. We don't know if all these things we're doing are sustainable. We just don't have enough of a record. We don't even understand all the variables in the system. So if we don't have enough of this kind of ecological lifelines supporting us, supporting our communities, providing us with places to find refuge and solace, we're just missing the plot. We've lost the plot in terms of what we need to do as an ethically and scientifically competent species.
We need to have resources, obviously, from forests, but what we need to do is to establish two kinds of forests. One would be forests that produce resources, and forests that are here to protect the planet. So in addition to these resource-producing forests, we need to have enough forests that provide these essential services. So we need to establish enough strategic biodiversity and carbon reserves in order for the planet to keep functioning properly. So then the question is, what fraction of our forests need to be in the category of reserves? And there have been a number of estimates of that. E.O. Wilson said basically not just for forests, but said nature needs half. And interestingly enough, in the most recent panel on climate change reports, it recognizes, actually for the first time by the climate scientists, the essential importance of biodiverse ecosystems for maintaining a livable climate. And the numbers they suggest are a minimum of 30 to 50% of all ecosystems need to be essentially what we would call reserves. My own sense is that that number may be too low. If you think of the Earth as a living planet and ecosystems as vital organs, imagine a human being. As a human being, I could give up one eye, I could give up one kidney, I could give up one lung, I could give up one of everything I have two of. But this is saying I have to give up all of those things. I don't think I could function giving up half of all my organs. And I don't think the Earth can either.
We expect forestry professionals to know how to keep us supplied with the wood products we demand. But can we expect them to know everything about the complex biological processes of forests? No, no one can be expected to have that much knowledge. A storm does not just sever a tree trunk and remove the wood. It breaks and uproots trees, creating new microhabitats. Nor does it damage the forest floor and compress soil like machinery does. Forestry does not mimic natural disturbances. Foresters make decisions about what trees and genetics are removed, not nature. Foresters are now promoting the idea of using chainsaws to create old-growth characteristics in younger forests. At what age would they then leave the forest alone? If they don't, then what's the point? The dark shaded areas on this map show the watersheds of New England and eastern New York that have a 100% ability to produce clean water. It's interesting how that corresponds to the areas that have at least 95% forest cover. Much of the world's forest land has become desert, treeless, or degraded by man's activities, and that trend is continuing. Of the remaining forest regions, only remote places have large, unfragmented forest areas most capable of maintaining all their native biodiversity. Atmospheric physicist Anastasia Makarieva points out that the vast majority of measurements of atmospheric processes are made using so-called flux towers outside of the intact forest regions, which are remote and difficult to access. And global studies of ecosystem resilience, too, are made outside of these natural, self-sustainable, resilient ecosystems. So, if we don't study climate parameters over large, intact forests, how can we accurately judge what effects our manipulation of forests have? How can we evaluate the resiliency of managed ecosystems if we don't study the intact and recovering ecosystems in all ecoregions? Of New England's nearly 72,000 square miles of land, about 25% is currently protected to various degrees. Only about 3% is classified as wildlands and dedicated to proforestation. In our collective long-term human memory, there is the knowledge that we owe our very existence to the natural, forested world that supplies our most basic needs of clean air, pure water, shelter, essential products, recreation and solitude, wildlife, food, and livable, moderate climate. Yet, over centuries of time, our species has exploited and severely damaged the foundation of our well-being. Can we continue this way and still prosper? Not likely. Given that no one can be expected to thoroughly understand the complexities of how forests have created our stable environment, would it not then be wise to let nature manage as much as possible of what nature itself has produced?